practice and operation. So as a preliminaries, what is a drilling operation? Drilling operation is a process to create a path which connects the surface and subsurface environment. So basically, we create a hole into the well as per the term itself. The objectives are to extract the natural resources. That's one of the aim in oil and gas industry. For the injection of a fluid from surface to subsurface reservoir. So at some point, there are cases where we want to throw away some unused or pollutant that we have produced during drilling operation back into the formation itself, whether it's for safety or even to increase the production of a well, which is part of the enhanced oil recovery segment later on. And then the other objective for drilling is to subsurface formation evaluation or monitoring. So in order to develop a well, an oil field or gas field, we need to perform continuous improvement, continuous data gathering, and one of them is to do drilling operation by getting some more information to develop and grow further. So that's the other objectives of drilling operation. So before we go further to drilling itself, so there are, I think I'd like to deliver a little bit about drilling, the entity that is involved in a drilling operations. So just so that we are all understand on the same page later on. So the first is about drilling operators. So what is drilling operators? They are the oil and or gas company that has successfully tendered for a field and owns the mineral rights of a blocks, lease and permits to explore in a particular area. They are responsible to plan the life of the well and specify the material and labor needed to develop this well or develop this field. They are responsible to order the necessary materials and equipment and personnel and recruit contractors to grow this field and produce the hydrocarbon. They are also the drilling operator is ultimately the entity that is responsible for the project. They win the contract of the tender of the blocks, and they deal with the government and all other official bodies that is required to operate in this well, in this field. They can be either a national oil company or an international oil company, whether it's government or private sector. So these are some entities that I believe you are familiar, that is commonly known as a drilling operator. First is Pertamina, we got ExxonMobil, Chevron, we used to have Total in Indonesia, Statoil as well, CNOOC, Shell, Medco, our local Proud, and Petronas, ConocoPhillips, and so on. So these are the samples of drilling operators. The second entity that is involved in drilling operation is we call them as a drilling contractors or a rig contractors. The drilling contractors responsible to supply the rig, and they can be a single company that own the rig or a small group of companies that are pooling resources to do the drilling operation. Supplying the rig and crew are they responsible, and sometimes it is completed with consultants or specialists in a case by case. For example, in an ultra deep water operation, HPHT operation, extended reach wells or horizontal wells. So some special criteria where extra care is required in the operation. So they are responsible to provide this. Basically, drilling contractor is the same to rig contractors or the rig owners. These are some of the famous drilling contractors in the region. Valaris used to be Noble and Ensco. We also have Seadrill. There's also Shelf Drilling, Sapura Energy, Coastal, Transocean, and Maersk as well. And last but not least is the service company. Who is the service company? They are the people or entities that fills in the supply gaps for the contractors, between the contractors and the operators, including but not limited to physical products, services, logistical, supply chain, software, and training as well. They get called out to the rig on a time to time to perform specific duties as agreed by the contractor, the drilling operator. There are also many parts of drilling and completions operation, but the contractors or the operators, they have the audacity or the exclusivity to call out not all of them, so just part of them. So in well A, we may require specific services, but in well B, that services might not be required, so they don't get called off or utilized in the second well. So many of the roles of the service companies are only needed occasionally, as mentioned before, or are very specialized. For example, drilling fluids, there's specific company who works or focus on drilling fluids, cementing services, wireline, or mud logging service expertise, and liner hanger, managed pressure drilling, underbalance drilling. So a lot of service companies that focus in specific area. But some service company, they can have more than one product line or business unit, as you call it. So like, for example, Halliburton, they have Barrowit for mud specialty. Halliburton also have cementing services. They also have wireline, but they don't have mud logging. So mud logging, for example, some company that focus in mud logging are Geoservices, Geolog International, and Xlog as well. So these companies, sometimes they provide the whole range of services required, but other prefer to have focus only in one or two products or services. So that's about service companies. To drill a well, for example, in this case, in this schematic, you see, you see that to drill a well, the drilling operator will be responsible to provide the rig, mud, directional drilling, cementing, casing, wireline, all of the services that they think is required and to attain all the data correctly. But however, it takes more than one entities to drill a well, so collaboration is a must and mandatory. So for those who doesn't understand that, because I was under the impression by the time I was in college, I was under the impression that Chevron is the one who owned the rig, Chevron who provide the mud logging services, Chevron is the guy or the entity who provide their own, what do you call it, mud services. So it's all on some uninformed people like me was before. So it was incorrect. So the correct term or thing is there's always a separate and fixed line between drilling operator and a service company. The next chapter will be about the types of wells. So there's a wells that we call it wildcat or exploration well. Close to none information about the subsurface. Sometimes no data at all, where we call it a wildcat. And in exploration well, you normally put a lot of risk over there, and sometimes you put extra measures for safety. You put more cost for logistical because it's a remote area. And in exploration wells, apologize for that one. Sorry, I forgot to turn out my WhatsApp. Okay, now we're good. Apologize on that one. Okay, so about exploration well, Indonesia in 2020, we don't have a lot of exploration wells as it was back in 2015, 2014, where hundreds of exploration wells was approved by SKK Migas at that time. But due to the downturn, the second downturn that we have right now, the exploration does not flourish, you can call it that way, and very limited. Everybody is trying to save costs and minimize their capex and their expenses to their operation, so that they can sustain the current downturn, and maybe they can keep their employee longer by being more economic at the same time. The second types of wells are appraisal well. This is to determine the size of the field. So once you drill the exploration well, you go drill 2, 3 more wells, 4 more wells, depends on how fast the field you assume. And by drilling appraisal wells, you can understand that whether your blocks are economic or not, are good enough or not, are sustainable enough or not? Does it contain good pressure that is economic for another 20 years? Does it contain massive volume of hydrocarbon that can make the company grow and sustain for another 20, 30 years, especially in that country? So appraisal well, wildcat or exploration, normally you only drill 1 or 2. And then appraisal wells, it takes 2, 3, sometimes 5, depends on how wide is the area. And then the third type of wells is the development wells. Development wells is once you do your exploration wells and then the appraisal wells most of the time, not always, but most of the time after they do exploration, then the appraisal wells, then they can start the development wells. Development wells is drilling a lot of wells that require immense effort to do the calculation, to prepare all the program, all the cost, all the budget, where the money came from, will SK Chemigas or regulator approves this, and another important thing is it going to be economic to be developed? Because you drill 3 wells, it seems you drill 1 well, it seems economic, and then when you drill 5 wells in total, including the appraisals, and then it turns out it's not. It's only a small block, small basins that does not sustain for another 5 years, probably. So they don't proceed to the development, and then they stop over there. But once the SK Chemigas review and agree with the plans, they will challenge the drilling engineers, and most of the time it's the reservoir engineers who creates the plan for the oil field development. So once this is challenged to the drilling operators and challenge accepted, and they can proceed and get approval and start the development phase of that particular blocks. Infill drilling, it is what do you call it? Drilling between existing wells to increase production. So basically, you have a set of pre-drilled development wells already in that particular blocks, and then you think that you can increase some more, maybe by drilling at this particular spot in between well A and well B, where there might be a small lenses of unproduced trap, and then you go with infill drilling. And then delineation well, it's kind of a not necessarily exploration, but once you found the border of the field, and then you try to find and push further. Of course, after the blessing from the GNG and subsurface team, saying that, guys, I think there's a chance that we can drill further toward the east direction and try to find something better at that area, and see if we can enlarge our reserves by drilling some more and getting some more data. So that's what they call delineation well. The other one that is quite common is re-entry wells. Re-entry wells is, as per the term, is when you have a well that is existing, and then you do the re-entry to deepening or sidetrack or whatever that you need to do over there to increase the net pay, maybe to clean and to reduce the formation damage by acidizing. And then before you acid, you do deepening because you were sure that there was some settlement at the bottom, this and that. Basically, a lot of drilling stuff, but needs to be approved by the workover and the drilling service system most of the time. So that's the types of the well. There are 6 main types. I believe there are some more to this, but because it's not famous, I don't put it here. Next will be about the well construction. So a typical well casing diagram is like this. You have a annulus C, annulus B, annulus A, and a tubing section. So this section are mainly divided by the cased or casing, you call it. It's a big pipe that is we installed in the well so that we can stabilize the well, keep contaminants and water out of the oil system, also prevent oil from leaching into the groundwater. Casing is installed in layers, so in sections of decreasing diameters that are joined together to form casing strings. So, for example, you drill a 24-inch hole section, and then you install a 20-inch casing size, and then you run in the hole your VHA 17.5, and then once you reach target depth, you install the casing 13 and 3/8 or 10 and 5/4, 10 and 5/8, and then you drill 12.25 hole section, you install the casing in 5/8 over there. You drill 8.5, install a liner or casing 7-inch. So this goes on and on. So it depends on how the drilling engineers, if you're interested to be a drilling engineer, and you will need to plan this ahead. And if you're in an exploration well, sometimes you have to prepare a contingency section. So for example, you want to drill with 4. Normally you drill with 4 for a type of casing, maybe 20, and then 13, and then 9, and then 7, and so forth. But at this point, you might prepare as a backup just in case you don't reach target depth, because it's an exploration well, so you don't know what's going to happen, and you prepare a contingency basically. So if you don't reach target, the 12.25, the first thing that you're going to set is the 10 and 5/8, and then you drill a little bit smaller than the 10.5/8, and you set up the 9.5/8. It's possible. Depends on whatever you have and what have you planned. And there are some, as mentioned before, there are several types of casings. First is conductor casings. This is the outest casing and the shallowest casing that we have in the rig site. Normally, it's only a couple of feet down there from the surface. Surface casings, sometimes it's up to, and then smaller than that, intermediate casing. So this is more focused on the tackling the subsurface issues, for example, wellbore collapse, prevent any to set up or to mark your fracture gradient point. Because once you set the casing, then that end of the point is the safest point that you have. The target, the TD of the casing is the safest point of your fracture point. And then production casing. Production casing is the smallest casing that you have in the well. Mostly, as per the term, production casing is used for producing the hydrocarbon. So in South Sumatra, they have a big bore 7-inch by 9.5/8 production casing. And in most of the operation, they have 4.5, 3.5 size of casing or tubing. So there are 4 types of casing that I propose here, or I mentioned here. So conductor, surface casing, intermediate, and production casings. In between, you might have surface casing 1, surface casing 2, or intermediate casing 1, intermediate casing 2. Depends on the contingencies that you have prepared during the engineering design. And then move on to the types of the directional wells. So the wells, there are vertical wells. There's also a directional wells. In vertical wells, you drill straight, nearly a couple of degrees, maybe 1, 2, 3 degrees is still acceptable of inclination. But in directional wells, you have this special design of the well, trajectory and azimuth and inclination. So there's a special service company that do this. Schlumberger have this, they call it Anadrill. The Halliburton, they call it Sperry. Weatherford, they have precision drilling services. Baker, they have direction as well. Local companies such as Parama, there's also a directional services locally. And the purpose of directional services is to create a well that is not vertical, intentionally. So in this course, I will discuss 4 types of common shape or diagram of a directional well. The first is build and hold. So, sorry, this is build and hold. Apologize on that one. Why does it switch? Right. Right. Okay, the first schematic is the build, hold, and drop. So this is what they call it build. The first green section is build section, where we start to directional by kicking off from the vertical point, and then we stay in tangent section, and then start dropping off until we reach the target depth or pay zone that we want. So the first type of ada JNE Silvi, JNE. So the first type is build, hold, and drop. It doesn't always have to be like this. The drop can be only slight drop and then meet the pay zone immediately. Sometimes it goes back to vertical and before it touches the pay zone. So it depends on the discussion between well planner, subsurface team, and the drilling engineer. Then the second type is build and hold. Build and hold section is the first you do vertical and then kick off, start deviating the well, and then go straight until you reach the pay zone where you touch the pay zone with the tangent section. So this is the build and hold type. The third is the J shape. J shape is, as per the term, it's a J type of well. So vertical, and then you build and then finish the well at that point. However, if you drill further horizontally toward the lateral section, then you will end up making a horizontal well, or sometimes they call it extended reach well. So these are the 4 types of directional wells. So with the vertical, total is 5. So 1 vertical and 4 types of directional services. Okay, so is there any question about this one? About the first 2 chapters of this course? No? Maybe, so we'll move on to the fun quiz then. So who can answer this? What is the casing type that is used after the well reaches target depth and ready for production? Anyone?
If anyone want to answer, just unmute and answer the questions.
Yeah, I think that would be a good idea, because if you are mute, then you cannot hear it.
Can I try? Can I try?
Yeah, of course. Go ahead, sir. Please introduce yourself, mention your name, and then you can go straight with the answer.
Okay. Hello, everyone. My name is Rayvan. I'm from Pertamina University. And the answer is production casing.
Yeah, all right. You're good. The answer is correct. So, so I'll move on. Only 1 question. Next will be about the rig system. So for those who have petroleum engineering major, I think most of you guys have got this course before, but if you have any question or concern, just let me know, and then I'll try to answer my best. Drilling rig. Drilling rig is a device that is used to drill, case, and pump cement and complete the operation of the drilling operation. Based on the environment, we have onshore or land rigs, offshore rigs. It covers the floating and bottom support on the offshore. As for the floating or the floater, there's a type of drill ships, there's a type of semi-submersible, there's also a dynamic position semi-submersible and a fixed or anchored semi-submersible. As for the bottom support, we have a jackup rig, platform, gravity base, and some more, basically. So this is the type or sample of a land rig. I think we have a lot of land rig operation in here in Indonesia. We have Pertamina EP, most of them are land rig. Medco, also land rig. And some Chevron, Exxon, land rig in Indonesia. So these are the magnitude of a land rig operation. Depends on how smart you plan the well, and the well pad can require massive area and also can be minimized as small as possible as long as you can deal with the society and the local government. And for the floating rigs, we got the first one is this is a drill ship, and then this is the other two is a semi-submersible. So the semi-submersible is used, these two basically, drill ships and semi-submersible. Most of them are used or operated to drill a deep water, medium to deep water operation, and some even a ultra deep water operation. In a shallower area, where you can step on the foot of the drilling rigs, you can utilize the bottom support rigs. The first thing, this is gravity based, this is a gravity based. So basically, these two, they have a massive, what do you call it? A massive leg, long, very, very long legs that can step into the bottom of the seafloor. Then they can start the drilling operation. And this is a jackup type of rig. The jackup rig is they can lift their legs up to a certain position, and then they can be towed and mobilized from one platform or one drilling area to another. And basically, as well as a gravity base, they can move. So if I remember correctly, gravity base, there's a big, what do you call it, chamber at the bottom of this concrete. So inside of the concrete, there's a big chambers where you can fill out with water or air, so that if you feel a lot of air, then it starts to float, then you can start towing this rig into the desired position. The same principle with jackup, but just a different method. For jackup, you lift all the three legs. Sometimes you got, most of them have 3 legs for the jackups, yes. And you lift these legs off from the rig floor, then tow to the next position or next location where you want to drill. And then once you reach that position, whether it's a open water or a platform, in this case, the jackup will drill in the platform. You can see there's a platform over here. Then it will start the operation by extending the cantilever deck. But if it is in a open water, there's no platform. There's a special deck that exists or present on the bottom of the rig here, around here, on the bottom of the hull. They call it a BOP deck or something, if I'm not remember. Texas deck. They call it the Texas deck. So the deck is used to set some light equipment over there, but basically everything is supported by the mud line suspension by the seabed. Okay, so based on the water depth, 150 meters, you can use platform or jackup. It is rarely that we have jackup that can drill up to 150 meters water depth. most of the one that we have in Asia or Indonesia up to 110, 112, and 20 meters. But some special jackup, they can the leg can be extended that they can reach up to 150 meters. For semi-sub, anchored, and drill ship without dynamic position, they can drill with the water depth up to 1.5 kilometers from the surface of the water. And semi-sub and drill ship, they can drill the deep water operation 3,000 meters or more because they don't need to step anything to the bottom of the sea. And okay, so this is not a rig. This is not a drilling rig, but I feel I have the responsibility to address this to you guys. So platform, fixed platform, they are a means to support the wellheads and the conductors on the surface. But in the end, when you drill, it's always another rig coming from outside, such as jackup or tender assist rig or a drill ship. Not drill ship, platform, mostly a jackup and tender assist or barge. So another rig comes, they bring all the service company on board, and then they come to each of this platform, depends on which operation that they're going to operate. So for example, a jackup, they will operate in fixed platform. So they will tow the jackup body here and then start connecting to the platform and then set up the BOP and then start drilling. But in a deeper condition, maybe an anchored type, there's rarely in the semi-sub they don't have any platform. But basically, once the rig is finished and the wellhead are completed, then they will have to choose whether they want to have a surface production facility or subsurface production facility. If they want to have a surface production facility, then they will have to choose for a medium or deeper water. They would have to choose one of these type of platforms. Depends on the condition of the area, depends on the depth of the water, and also the cost, of course, whether it's economic or not. Moving on. So in Asia, this is a little bit trivia. In Asia right now, as per July 2020, we have these rigs operating. So this is, you can call it quite small volume. So there's only 6 semi-submersible rig operating in Asia. It means it covers the whole Asia operation: Myanmar, Thailand, Indonesia, Malaysia, Brunei. So the whole Asia, there's only 6 floater semi-submersible and drill ship operating as per today. And I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 jackup operating. So there are 6 and 12 offshore operation right now running in Asia concurrently. And this is a quite small amount considering Asia have a lot of active oil and gas companies, and they need to sustain their volume of contractual needs to supply, whether it's gas or oil. However, in Indonesia, as per today, we have 7 jackup rigs and 1 tender assist rig. So you can consider 8. So out of the 12 jackups, all of them are 7 of them are in Indonesia. So you can call half of the rig right now actively operating in Indonesia on the offshore, so to say. However, there are a lot of other rigs that is not in a good condition. Maybe the contract runs out. And the warm stack rig, we have 19 jackups, 4 drill ships in Asia right now under construction. Yes, they do still produce or fabricate rigs. Maybe it's to fulfill the commitment that they have agreed before the pandemic and the downturn of the second downturn in 2020. And 8 jackups in the cold stack and around 8 jackups in the scrap in the past 9 years. So here, these are all the statistic that I got from Restart Energy. And from this, you can see that a lot of rig is not operating right now. And it's a very sad condition for the industry, but we still have some more operation running in Indonesia for offshore. This calculation is only for offshore because onshore is very difficult to keep track on. But we have a lot of onshore operation right now, especially with our friend in Pertamina EP, and Medco not so much, but we also have Pertamina, even PHE. Oh, sorry, Saka Energy. Even they have a upcoming land rig operation. Previously, they were in offshore Java, West Java. Okay, so that's the rig activity in Asia right now, as per today. Okay, any question until that point? Question 1, number 2, and okay, go. The next chapter will be about the components and mechanism of the rig system or drilling system. I believe most of you have known this. There are 5 types of the rig components system. First is power system, and then hoisting system, circulating system, rotary system, and well control system. Someone is unmuting. Okay, is there anyone to ask any question? No? Okay. Okay, power system. The purpose of the power system is to generate the electrical power that is used to operate all the rig and the service company system. Most of the time, it's diesel-powered internal combustion engines. Sometimes they do bring electrical stuff as well. But most of the time, it's diesel-powered. So this diesel and power generator, it will create and supply power to the prime mover to create electricity or to create mechanical force to operate the rigs. And basically, it's a power source. It's a power system generated by the generator. A hoisting system, it is a large pulley system which is used to lower and raise the equipment into and out of the well. Sometimes they also used it to lift some very heavy equipment at the site, but rarely. The components of hoisting system consist of drawworks. There's also fast line, dead line, crown block, traveling blocks, hooks, and elevators. So drawworks here, this is the primary source of the rotational, so that all of the fast line will be pulled in or stretched out back in order to move the traveling blocks through the crown block to reduce the force required. It's physics. Okay, so for fast line, this is the line that will move stretching in or stretching out in order to reduce or increase the length of operable line in the derrick, in the mast. And then traveling blocks, this is the intentional or the objectives of the system. It needs to move the traveling blocks up or down, but in order to do that, the fast line needs to be lured in or lured out from the drawworks or by the drawworks. At the end of the fast line, there's what we call it deadline. The deadline is anchored at some point at the rig site, most of the time at the corner of the rig floor. So you want to have this dead all the time, fixed all the time. You don't want this to move, because if this move, it means that the traveling block is at loose condition and it may fall and drop into somebody. So that's about the hoisting system. You got drawworks, fast line, dead line, crown blocks, traveling blocks, hooks, and elevator. And then the circulating system. It is its function is to circulate drilling fluid down through the drill string and up to the annulus, also to carry all the drill cuttings from the face of the bit to the surface. So the components are mixing hoppers, mud pits, mud pumps, suction pit, standpipe, Kelly hose, drill pipe or drill string, bit, and when it returns back to the annulus and back to the surface, it goes to the mud conditioning system, which consists of shell shaker, descender, desilter, degasser, whichever applicable that can be used. So in the flow here, it's from the suction pit or the mud tank, and then sometimes they got specific mud tank to collect and then transfer to the suction pit so that they know what is the requirement, the exact volume. And then once it's in the suction pit, it will goes up into the mud pump and then pump into the standpipe. The standpipe picture is here a little bit minimalist, but in actual, standpipe is like a network of piping where you can have when you can change from standpipe 1, standpipe 2, or the other way around, and a lot of valves involved in there. But basically, the purpose of the standpipe is to connect the fluid from the mud pump to the Kelly hose. The next part will be about the Kelly hose. Kelly hose is the start from the end of the standpipe. Apologize. At the end of the standpipe until it reaches the swivel. So the Kelly hose is a high pressure hose, flexible enough because the Kelly hose will experience stretching in and stretching out as the swivel move up and down, and that will be moved by the hoisting system, which is the traveling blocks. And then from the swivel, the mud will go into the, whether it's a Kelly, if not, then it goes straight to the drill pipe. Then it might go to the drill collars and all the BHA, bottom hole assembly, and then it will be discharged at the end of the bit through the bit nozzles, and it will create a high pressure into the downhole, which hopefully it is the cutting dismantle by the bit, and then the mud and the cuttings will move and travel through the annulus to the surface, back to the shell shaker to be conditioned by the mud conditioning system. If there is any gas or any sand, if there's any sand containment during the drilling in the cuttings, and then they will operate and divert to the descender. And then if there is silt needs to be cleaned out from the mud as a contaminant, they pass it through the filter to clean out the silt. And if there's any dangerous gas, they pass it to the degasser. So that's about circulating system. The rotary system or rotating system, the function of this system is to rotate the drill string and therefore the drill bit on the bottom of the borehole. And apologize, guys. Okay, right. And then it moves the rotating system moves the drill string, basically gives the rotational force to the whole string, to the whole pipe, to the bit. So the hoisting system provide the vertical force up and down, but the rotating system will create the rotational to the drill string that we lift by the hoisting system. The components of the rotating system are top drive, rotary Kelly bushing, rotary table, Kelly, and swivel. If you are in a recent operation of the drilling, you rarely find a rig which utilize a Kelly anymore, because most of them are using top drive right now. It creates efficiency, flexibility, and improves the operation, especially the pipe connection operation. So it saves a lot of time by utilizing the top drive and removing the Kelly system. So basically the rotating system, all about the rotating system, you got the top drive, rotary Kelly bushing, rotary table, Kelly, and swivel. And then the last but not least system is the well control system. This is one of the most important system in the drilling operation. Well control system, it prevents the uncontrolled flow of formation fluids from the wellbore to surface. So it's a safety measure. The components are a diverter, annular preventer, ram preventer, blind or shear rams, choke manifold, hydraulic control remote valves, and choke and key lines accumulators. So the diverter, it is a low pressure containment device that is used to divert a fluid in a shallow gas operation. So when you drill a shallow gas, you don't have time to perform the well control. What you can do is route it to the diverter, shut in the diverter, and prevent the gas pass through the rotary table, and then it's diverted to the at the end of the diverter line. You can burn it as well. And second is annular preventer. Annular preventer, most of the time it has a higher pressure rating, sometimes 2000 psi, sometimes 5000 psi. Most of the time it's 5000 psi, and most of the time it's 2000 psi. Sorry. The ram preventers, it's a pipe ram, also commonly known as a pipe ram. It has a lot of variations, but a little bit different with annular and pipe ram. Annular preventer, it has the capability to stretch in and stretch out a little bit when the drill pipe pass through it, if it is required. But pipe ram or ram preventer doesn't have the exclusivity, because pipe ram is a fixed size. So once you have a drill pipe, okay, I want to drill the whole section with a drill pipe 5-inch. So before you start running whole the BHA, the pipe ram face need to be set or replaced into the 5-inch type. If you drill with a 4-inch or 4.5-inch, then you need to adjust and remove the 5-inch piece and then install the 4.5-inch. So this is the kind of preparation that we need to do and be aware. Blind and shear ram. So the diverter, annular preventer, and ram preventer, they have the capability to hold the drill pipe and prevent the annulus fluid migrating or traveling to the surface. However, the blind or shear ram, this completely shut down the well and cut anything that passed through it. So it will cut, if it's drill pipe, it will cut the drill pipe. If it is a drill collar, it will cut the drill collar, yes. And then number 5 is choke manifold. Choke manifold is it is a system that is used to increase back pressure on the surface, so that if you increase back pressure, it will increase the bottom hole pressure of the annulus system. And at some point, it will be utilized for a well control operation later. And HCR valves, this is hydraulic control remote valves. These valves are required to manipulate the surface pipeline, the surface flow during a well control, and also to increase the efficiency as well, because if you are under high pressure on the surface pipeline, it is more safety if you use a hydraulic control remote valves rather than the manual gate valves. And then number 7 is choke or kill lines. The line is used for connecting between the wellhead and the rig choke, or to, if it's a kill lines, to connect between the standpipe into the wellhead. Because choke line is for the return and kill line is for the inlet. Both of them are into the annulus. And number 8 is the accumulator. Accumulator is part of the well control system because the accumulator will provide hydraulic power to activate the piston in, to activate the piston in diverter or annular preventer or pipe rams or blind and shear rams, so that it can shut in through the annulus. So everything is remotely operated by the accumulator. Whoop, sorry. Any question about that one?
There's actually have a questions.
Yes, go ahead.
The first one is our dual ram rig has commercially used in a lot of offshore oil rig operation.
Dual RAM?
Has commercially used in a lot of offshore oil rig operation.
Oh yeah. Are you talking about which pipe ram?
I think for the for F1, you can unmute and get the conversation with Mr. Fikri.
Yes, thank you, Mr. Fikri, for the explanation before. I just want to have a career. I just curious about how commercially used is the dual ram rig, because as before I've been joining an oil rig design competition, and I'm in charge of calculating the economical, but I see that the dual ram rig is offer an efficient system to bring well, because it use dual system, use dual top drive, and it make the
Oh, double tower.
yes,
Okay.
that's it.
Okay, I understand. Dual RAM and double tower. Okay, okay. You call it from what you said, in my understanding, it's called double tower. Okay, go ahead. So you want to know about dual tower rig?
Yes.
Okay. Yeah.
When I
So yeah, go ahead. Go ahead.
okay.
Continue your question.
When I'm calculated the economy, I see that the dual tower is much higher and expensive than the single tower, and I'm just curious about is it commercially used, because it's over a great advantage of drilling operations.
Okay. Yes. Thank you very much for the question. Yes, dual tower rig do exist and are commercially used in the world right now. Though I would not say I know precisely the quantity, but dual tower rig mostly what do you call it? Pre-equipped in a offshore deep water operation. For example, floater. Most of the time, a drill ship. Most of the time are drill ships. And I rarely see a no. I think the EDSCO 8504 they have double tower. So dual tower rig, they have two mast, two derricks, two top drive, two everything. Yes. Okay. So back in the day where the oil price was 128, $130 a barrel, and the operation was back in 2013, 2014, 2015 still. Okay, so at that point, all the rig price, daily rate are very, very expensive. So, for example, a drill ship in Indonesia, one of the drill ship operates in Indonesia back in 2013, 2012 is the Transocean. I forgot the name. What rig? Yeah, but basically, the daily rate of the rig itself nearly $1 million a day. Okay, $1 million a day online time that whoever used that rig needs to be paid to the drilling contractor. Okay, so $1 million a day, that translates to how many per hour? So 1 million divided by 24. So that's 41 million. Okay, divided by 24. So that's 42,000 that the company have to expend every hour. So to run a deep water operation, for example, a marine riser, to run it, it takes 1.5 days. Depends how deep of the water depth. 1.5 days, that translates as 1.5 million. Okay, in a dual tower, you can cut that by half because not because it has to run everything dual tower, no, but because I believe you understand about the dual tower as well. So one tower will run online. The other tower will pre-assemble things that can be run online later on. So by cutting this hidden time, yes, maybe the rig needs to be paid at, instead of 42,000, the rig maybe will be at 50,000 per hour. So that's a difference of 8,000 per hour that they save, that they need to pay, right? However, they can save up to 750,000 per day. So 8,000 per hour multiplied by 24, that's so many hours, so many millions, so many 100,000, let's say 200,000. And then they spend 200,000, but they save 750. That's a way to look at it. I'm not sure whether it's still economic right now because everybody have pulled off their price. A lot, not much operation, low demand, and everybody wants to keep their rig operating. So instead of charging 1 million a day, now they charge the client at maybe 300,000 a day. So it's also adjusting to the market. But from my perspective, yes, it's still economic. Using a dual tower rig compared to what saves that they made. So I think what you need to investigate in the future for your economic calculation is make sure you know what actual operation is going to happen, because you might skip one of the economic calculation where a dual tower need to prepare this instead of instead of calculating one, you can calculate it by half or maybe 60% only. So just make sure you be more specific in the activity that you calculate in your economic calculation. I think that should translate to a better number later. It's not that your calculation is wrong. It's just that maybe, just maybe, the actual activity where you can save money by paying some more is not there. I hope that answered to your question, Ivan.
Yes, thank you, Mr. Fikri. And I think the investment will be worth it if the situation is not just like in this pandemic. And I think from your explanation, it will cut a lot of non-productive time. So the overall operation expenditure will be lower, but the
Yes.
Capital expenditure will be higher, but it will be much worth it if the situation of the oil and gas prices is also high.
Yes.
Thank you.
So for example, there's a case recently, I'm working in Weatherford right now. So I also, my focus in managed pressure drilling. So one of the revenue or the business stream that I work is capital sales. Capital sales meaning you sell big items to whether it's a drilling company, drilling contractor or to operator. So for example, at the last, I think end of 2019, one of the rig company, they call it Blue Whale. It's a Chinese brand, Chinese flag. So it's a very big rig semi-submersible that they own. It's one of the biggest semi-submersible rig that exists in the world right now. But they're planning to buy an MPD capital worth of, I think, $10 million. Because the client who requests for rig is making it mandatory for the rig to have a MPD ready. So the client, Santos at that point, Santos in Australia, they issue a tender for a floater or semi-submersible rig. And then the tender makes the drilling contractor who wants to participate, they have to have MPD system on board of the rig. So, and then the rig comes back to Santos. Okay, how many wells? okay, we're going to drill 15 wells in 3 years from now. Okay, so now 15 wells will have to be invested or divested into the 10 million capital sales, where the blue whale will have to purchase to Weatherford capital, right? And then, so they will have to calculate everything. So 10 wells and, 15 wells, 3 years, they'll have to calculate all the depreciations, all the costs associated to maintain the capital later on in the next 3 years, and then translate that number into the price that they will submit to Santos later on. Yeah, Santos already understand that the price will be higher compared to the price without MPD. But just like as your case, if Santos is asking for a dual tower rig, Santos are ready with a bigger expense and capital upfront, because they cannot bid or they cannot get a single tower rig with the price. They cannot get the dual tower rig with the price of single tower.
Yes, definitely. Thank you,
Yeah.
Mr. Fikri, for the explanation.
No problem, Ivan. Any more question?
Maybe Mr. Fikri can continue the presentation.
Okay, I'll carry on. Next will be about drilling problems. Several drilling problems, common drilling problems in the operations are, one of them is a stuck pipe. It is a term used to describe a situation in which the drill string cannot be moved up, down, or rotation. So there are 4 types of stuck pipe. First is because of the differential sticking. Second is because hole restriction. Third is because the cavings, and the fourth one is about hole irregularities or difference or incompatible BHA. And then another drilling problems is about loss circulation. Loss circulation is a non-controlled flow of the whole mud into the formation. And then there's a hole deviation, unintentional departure of the drill bit from a pre-selected borehole trajectory. There's also drill pipe failures, twist off, parting, burst, collapse. Borehole instability, the undesirable condition of a well bore falling into the annulus system and might create a stuck in the end, but it's because of the borehole instability. Mud contamination, changes in mud properties such as density, viscosity, and filtration. And another problem is hole cleaning. Also shallow gas zone. Hole cleaning means poor hole cleaning. In the end, it will lead to pipe stuck, yes. So, but the root cause is because the hole cleaning was not good. Maybe the mud rheology incompatible with the formation. Also, maybe it's not too, it's too light, not viscous enough to cut to bring the cutting to the surface. And maybe the gel strength is insufficient or whatever. And then the next one is shallow gas zone. So normally when you drill on the surface, you have a unpredicted gas pocket. And then what you need to do is just divert to the diverter and then let it flow. The other drilling problems is the well kick. It's a well control problem in which the pressure found within the drilled rock is higher than the mud hydrostatic pressure or the bottom hole pressure acting on the borehole. So basically the kick happens because the formation pressure is higher than the bottom hole pressure that you prepare when drilling. So there are 5 or 6 kick indications. The first is sudden increase in drilling rate, or you call it drilling break due to porous formation, potential pay interval. Normally, when you find a drilling break, you stop drilling and pull the lift the bit off bottom as soon as possible. You don't want to penetrate through a porous formation because the fluid in that formation might migrate and travel into the wellbore. Another indication is increase in fluid volume at the surface, which translates to the increase in the pit levels. Change in the pump pressure. A decrease in pump pressure during influx is caused by reduced hydrostatic in the annulus. So that's why when drilling, the driller also pay attention to the pump pressure. What is the normal pump pressure that they have, and then frequently, maybe every 15 minutes, every half an hour, he needs to pay attention to that pump pressure all the time for, I don't know, for 5 minutes straight to ensure that it is the correct numbers, no significant changes. Reduction in drill pipe weight. So when you drill, you have your hoisting system. In the hoisting system, there's a means to measure how heavy is the drill pipe right now in the well, or you call it a hook load. And then you have a drill pipe with the length, drill pipe and drill collars and all of the BHA with the length of 2,000 feet. And then up in the air without a hydrostatic column, the weight might be 1.5 million pounds. But when you put it into the hydrostatic column, it gets lighter. Maybe it only translates to 1.1 million pounds. But in the end, you don't drill with 1.1 millions. You don't fully lay the drill pipe and the bit into the formation with 1.1 million of weight. You put only maybe 500,000, maybe 400,000 pounds. So you hang it a little bit by the traveling blocks as you drill, and then if you want to drill faster, you give more weight by releasing the hoisting system a little bit. So that's it about traveling block. And then the last one, the key indications, is gas, oil, or water cut mud. This indicator is also normally accompanied by one of the other 4 indicators above if the well is experiencing influx or kick. So those are, I think, 5 only. 5. Those are the 5 indicators of kick. So moving on to well control. So once you have kick, what you need to do is to perform well control operation by activating the well control system in the field. So what to do with the well control system? What you need to do first is to shut in to close the annulus, so that you have a closed, perfectly sealed annulus system without return to surface, and everything is contained at the bottom, and no additional influx, hopefully no additional influx migrates from the formation into the wellbore. So that's the intention. So there are 2 types of shut-in. I know it's a bit too technical. There's a soft shut-in, also there's a hard shut-in. The difference is only because the choke position. The choke position in the soft shut-in is in open position. Hard shut-in is in the closed position. And once you do the shut-in, you need to do the observation. So how long needs to be observed? As long as you need. Sometimes it takes 2 hours. Sometimes it only takes 15 minutes. So depends on the condition of the well. If it's a oil-based mud, normally it takes longer than that. If it's a water-based mud, normally it's shorter than that one. Because if oil mud is being used, the observation needs to be lengthened, because there's a potential longer time for the system to get to its equilibrium state, where the gas that is diluted inside the oil-based mud to be released before it's fully equilibrium. A typical shut-in procedure: drill no more than 3 feet or 1 meters of once you see the drilling break. Pick off bottom and then flow check. If there is any flow observed, shut in the well again. Do not try to flow check further. Record the pit volume increase, drill pipe pressure, and the annulus pressure. Monitor the wells, and in the monitoring the wells, you need to check the drill pipe pressure until it is equilibrium. It's rarely reached to straight line, but once you are in the oil field, you know the feels when you feel that it's already equilibrium or not. And then shut in the annular or and open the pipe ramps. Prepare to displace the cake by means of the annular preventer. Circulating the influx, you need to understand the YouTube models. YouTube models here on the left side is the drill pipe area, because in the drill pipe you have a drill string area actually. In the drill pipe you have the ID of the drill pipe, ID of the collars and the bit as well. But on the other side, you have your influx, which is connected to the annulus. So this is the YouTube that was mentioned earlier. And understanding the YouTube, you must keep the shut-in bottom hole pressure constant or slightly overbalanced. So what you want to target when you see this YouTube is we want to have a small volume as possible of the influx in our annulus. So we need to keep or maintain or try to reach where the bottom hole pressure is constant. Constant meaning it's similar to the condition where the well is not in influx condition or well is not kick condition. Or even better if you can go slightly overbalance. So that's the target. And then common methods of well control. There are, I think there's some more than this. I think I bring it here. There are 8. Circulate and wait, concurrent method, and then reverse circulation, dynamic kill procedure, bullhead, volumetric method. Driller's method and wait method are the 2 main or commonly used well control in the IADC right now, in IADC guidelines and in the world of the drilling operation. The difference between driller's method and wait method is the driller's method, there will be 2 circulations. So once you have the influx, the first is you need to circulate the influx out with the old mud, and then the second is to pump in the kill mud without inducing additional influx into the wellbore until the kill mud is fully displaced into the wellbore. However, in the wait method, it's only 1 circulation, but the calculation is a little bit different, and the process is a little bit shorter, but needs extra careful. So the influx is circulated out together as you pump in the kill mud weight. For me personally, I like the driller's method because it's quite clear and straightforward. Some other prefer to have wait method. I think, oh no, this is the number 2 to this is the second chapter before we end. Drilling fluids serve many functions. Maintain the wellbore stability and well control, controlling the formation pressures, remove cuttings from the wellbore, seal the permeable formations encountered while drilling by creating the mud cake, cooling and lubricating the bit, transmit the hydraulic energy to downhole tools and the bit. It's also to be used by the directional team, directional services as a means to give command to the tool face of the BHA. So if you want to drill directional, you want to move to, okay, now we're going to change direction to the east, and then using the mud, the directional will create a pulse so that downhole, the tool face will slightly change to the east. Then they start drilling to the east side. So that's the drilling fluids functions or objectives. Drilling fluids are often referred to as a mud or drilling mud. It was first introduced around the early of 1913 for subsurface pressure control. There are several types of drilling fluid: water-based, oil-based, synthetic-based mud, compressed air, air or water fluid. So I think it should be air. Okay, water-based mud, it's the first three is liquid-based. The last two compressed air, and I think mist. The last one should tell you about mist. So the first three is liquid-based, but the other two compressed air is a gas-based, but the air or water is a mist. It's a multi-phase. It's normally used in a aerated drilling operation, geothermal operation, and the underbalance operation. So water-based mud, the base of the fluid is water. Oil-based mud, the base of the fluid is oil. Sometimes they use diesel oil as the diesel that we buy in the gas station. And then synthetic based mud is they create this special synthetic fluid commercially marketed, which have specific or some unique rheological performance, so that at specific area SBM might be required. Some brand that I'm aware about synthetic base mud are Escape, I forgot the rest. Line. Okay. Move on, air and polymer. So that's about drilling fluid. And then the last chapter will be about well completion. Well completion is defined as a steps taken to transform a drilled well into a producing one, or you want to shut it off. Common steps taken. First is to isolate the formation by installing casing, and then perform cementation to seal the annulus from potential micro fractures or micro gas migration, and then perforation, case hole completions with cement behind it for sure will require perforation to create holes and connect the well bore into the formation, and we can start producing the hydrocarbon from there. Number 4, open hole completion or barefoot, commonly known as a barefoot. The well is cased at a certain level, but at the bottom level, at the production zone, they left it open and create a special barrier down there so that it avoids any potential sand bubble. So that's some samples of well completion. Here's also a sample of well completion for you guys. There's a commingle single string with ESP, liner completion with ESP, horizontal well with ESP. So these samples here, all of them are using electric submersible pump. But in this case, they're using the ESP at, what's the ideal? 9 joints of 2.78. So at this one, they're using the 2.78 tubing with the ESP, and the well is a single string. This is the liner completion within a sidetrack well. They're trying to use the same configuration, but the other one is in a horizontal well. So that's the end of completion section or chapter. Is there any question for this course specifically about completion or the previous chapter, or any other drilling question related? Feel free to ask the questions.